Hi guys, I'm Prasad. Now I'm going to explain the criteria for machine dependent optimization. Basically, machine dependent optimization is done after the target code has been generated and when the code is transformed according to the target machine architecture. Now we are going to look at the criteria for achieving machine dependent optimization. The first criteria is that it involves CPU registers and may have absolute memory references rather than the relative references. In machine independent optimization, we can see that independent optimization involves relative references, but machine dependent optimization varies from that in it because it involves absolute memory references rather than relative references. And the second criteria and the important criteria is that the output code must not in any way change the meaning of the program. Like suppose some code is processed and the objective of the code is changed, then it's not going to be the optimization. The optimization is that the output code must not in any way change the meaning of the program. And the next criteria is optimization should increase the speed of the program, and if possible the program should demand less number of resources. This important, less number of resources. Like we are doing optimization to increase the program. It is also possible with machine independent optimization, but here in the case is that the program should demand less number of resources. And next criteria is optimization should itself be fast and should not delay the overall compiling process. Like the compiling process should not be delayed. It should not delay. And now we will look at the how to construct canonical LR parsing table. Construction of sets of LR items. Input. The input we are going to give to get the LR parsing table is an augmented grammar. Now what is augmented grammar? Augmented grammar we will look in the following slides. And like output is the sets of LR1 items that are the sets of items valid for one or more viable prefixes of G dash. And method. These are the functions involved in this parsing method. Function, begin, repeat. In function we have to calculate the closure of I for every function. And here we see that for each item A gives alpha dot B beta comma A in I. Each production will result in B gives to gamma in G dash, and each terminal B in first beta A such that beta gives to dot gamma comma B is not in do add. Like this is a procedure you can see. You have to repeat the number of steps here. Method, function, begin, repeat. Now I will explain with the following example. Consider the following augmented grammar. Now what is augmented grammar? Augmented grammar is nothing but adding this extra production, S dash due to S. Now we have the question, right? S gives to CC and S gives to C small c, but converting this to augmented grammar gives to this adding this extra production, S dash gives to S. Now we have to write the go to functions like S dash gives to dot. Like for every production you have to keep dot in front of it. S dash gives to dot S comma dollar symbol, S gives to dot CC, C gives to dot CC. This is augmented grammar. And yes, now we have to perform the go to operation. After performing go to operation we will get S dash gives to S dot. Here we can see if I perform go to for this production we will get this. I will get this production, and if I perform go to for this production I will get this production. And after performing go to, what you have to perform, you have to perform the closure, and after performing closure what I will get this production, C gives to dot CC and C gives to dot D. Here we can see I3, I4, I5, I6, I7 and I9. I3 is a production obtained after performing go to of this production, right? You can see here C gives to dot D, and I perform go to operation on this production. After that I got this production, C gives D dot. And look at here, C gives D dot. There is no symbol after dot. These kind of productions are called final items. Final items are something which we cannot do further go to process. Here we cannot do go tos. And look at here, see I6. Now I'm going to perform go to on these. SC gives to dot CC. If I perform go to on these I will get this. I6, C gives to C dot C, comma dollar symbol. And once I perform go to process, I immediately have to perform closure. And closure is nothing but writing all the production starting with the symbol following dot. Now what is following dot? C. C is following dot. So I'm going to write all the productions beginning with C. These two are the productions beginning with C. So I have written productions beginning with C. Similarly, we have to perform go to for I6, I5, I4, we'll get this, and after performing closures, we'll get this. So these are the canonical collection of items. This called briefly explain what we are given. Input augmented grammar, output is canonical LR parsing table, and what we have done we are going to see in a theoretical way. First we have constructed I1, I0, I0 and IN, which is called a collection of canonical items. And this is what I have seen. What is meant by closure? Closure means we have to keep the dot, and we have to move the dot by performing go to some closures till we reach the end. This is called final item, and this